I am a power sector engineer. I would like to bring some facts of the power sector to you. Presently, there are various challenges in the power sector, and today's discussion will be based on that. So, presently, the power sector is facing a lot of challenges. You know, the role of power sector is to generate the electricity. Here we can see. So, the system of power distribution comprises of the generation of the electricity, transmission of the electricity, and then distribution of the electricity. And all the three departments are tied up with the regulator that is called as a central electricity regulator or the state electricity regulator. So the businesses of the distribution, generation and transmission are regulated by the regulators. So the main role of the generator is to generate the electricity and sell it to the distribution company. And the role of transmission is to transfer the power from generating station to the distribution sector. So transmission is the system of the transport. It is a transport like in an industry, the product is manufactured and then it is sent back to the market. So it is sent back through the transporter. So just like that, the transmission role is there. So basically, I work in the distribution sector, but at the same time, distributor has to coordinate with the generation and transmission. And generation is based on the conventional energy and non-conventional energy. So today's topic we are going to discuss on the integration of the renewable energy. So presently in the state of Maharashtra, the total maximum demand is around 30 gigawatt. And in the near future, maybe by 2030, the demand is going to be up to 45 gigawatt. So lot of energy transition is there. Presently, around 60% of the power is coming from the fossil fuels. And of course, the use of fossil fuels is related with the generation of carbon emission. And the big challenge before us is to reduce the carbon emission. So in order to reduce the carbon emission, we are going to take various steps for integration of the renewable energy into the system. So in short, before we go for our main subject, I would like to bring some role of the distribution utilities. You can go through this. I will not explain the things in detail because I have been told that there is a limited time here. So voltage transformation, as you know, high voltage transmission voltage is to be reduced to the usable distribution voltage up to 415. The maximum voltage where transmission of the electricity is done is 400 kV AC, and in terms of now DC lines are also there. So up to 750 kV DC voltage is also available. So it is substantially reduced up to 430 through the primary transmission, secondary transmission, primary distribution and secondary distribution. Then network maintenance, the distribution company is having a huge network. It is having a number of substations, millions of the transformers. So all these networks, distribution lines, LT lines, ST lines, this has to be maintained. Then supply reliability and quality. Now there is a mandate for the distribution company to maintain the 24/7 supply reliability. So for this also we need to take some major steps. Then revenue collection. So although it is a technical business, but every business is having some commercial aspect. So distribution company has to procure a power from the generators, and then it has to be sold to the distributor, to the consumers. And in between, this cost of generation and cost of selling should match with some profit to the distribution company in order to have the cost for the maintenance of the lines and salaries of the employees. So this revenue collection is a big challenge before the distributor. Then metering and billing. Of course, there are many touch points with the consumers. Every consumer needs to be provided with the meters, and every month we need to take the readings of these meters. We need to go for the billing of these meters. So this is a tedious job. But presently, with the inception of smart metering technologies with automatic communication with the meter, so This task is becoming slight controllable to us. Then loss reduction, of course, when there is a transmission of huge electricity, there will be technical losses. Then primary point of contact, because the power sector distribution company is the primary contact for every consumer for a power sector. So it is not a generating company or not a transmission company which is going to meet the consumers. Consumers are facing to the distribution companies only, and their problems will be solved by the distribution companies. So giving new connection, handling maintenance and everything, these are the roles of the distribution companies. Then Maharashtra State Electricity Company is the state government company where it is established in the June 6, 2005. Earlier it was MSCB, which was comprising of all the departments like generation, transmission and distribution. In 2005, the distribution company, transmission company and generation company are separated, trifurcated, and then distribution company came into existence. So it is a government of Maharashtra enterprise. So ownership is a government Maharashtra. Core function, as I told earlier, the same function we are doing here. The scale is the biggest scale. It is second largest distribution company in the world and first largest company in the country. So it is the biggest distribution company in the India. Then over 29 million consumers are supplied power from this company, and the service area are roughly 3.08 square kilometer. Their infrastructure highlight, we can see network of high tension and low tension lines, transformers, agriculture connection and everything. So present power scenario we can see from here that total 1.39 lakh million units are consumed every year, out of which we can see around 30% is the consumption in the agriculture sector. In household sector, 26%, and the industrial is the big one. It is the bread and butter of the distribution company. It is around 58%. So with the 58,733 million units. The installed capacity wise, if we see, the total installed capacity is 40 gigawatt. So out of which we can see that the coal contribution is presently 21.5 gigawatt. And hydro is 2.8, RE solar generation is 7.8, and RE others, and nuclear and gas are having some share in Maharashtra also. So presently the renewable capacity in the Maharashtra is 41%, and by 2030 we intend to go beyond 50% for this renewable capacity. So unless and until we go for the more and more renewable energy, we are not going to reduce the carbon emission in the state. So these are the grids in the Maharashtra, where transmission grid, where we can see the transmission grids are generally operated by the MSETCL, Mahatransco, but at the same time, Adani Electricity, Tata Power and Jaigarh Power Transmission are also having some share in the transmission lines. So distribution grids are basically for the entire state of Maharashtra, MSETCL, but in some part of Mumbai, there is Adani Electricity, Tata Power and Best Undertaking. So the part of the Mumbai is taken care by these three companies, whereas beyond Mulund and onwards, MSETCL is the only distributor in the state of Maharashtra. There are some franchisee models we have done in areas of the Bhivandi and some part of the Malegaon. So it is a franchisee model. So franchisee means the ownership is with the MSETCL only, but this torrent power is given the authority to distribute the local power in that area. So the regional context, if we go, the entire grid which governs the electricity power balance is the western grid region, regional western grid. So let us talk about the renewable energy. What are the renewable energy sources? So you know the conventional energy sources are coal, gas, diesel and thermal. So here we can see that the coal and thermal are the major carbon emission product, and presently the share of this coal and thermal is on the higher side in the energy mix in the state of Maharashtra. So we are going to introduce some non-conventional renewable sources. So non-conventional renewable sources are solar, wind, hydro and biomass. So out of which, the solar is having the lot of potential in the Maharashtra because we are blessed with the more than 300 days sunshine in the state of Maharashtra. Why we need to shift on the renewable energy sources? So basically, as I told you earlier, because it reduces the air pollution, it reduces the carbon emission, it is a sustainable and inexhaustible source because the coal stock is probably going to vanish in some near future. So this is the only reliable source of power like solar and wind. Then it reduces dependency on the fossil fuel, improves energy security, and it is having the low operating cost. Because the renewable sources are having the only investment cost and no running cost. So these are now getting popular in our country, not in the country, in the world also. So what are the steps taken by the MSEDCL to integrate the renewable energy in its power mix? So the first and major step taken in the state of Maharashtra is the solarization of agriculture feeder. So as I told you earlier, we are having around 30% of the agriculture consumers in the state of Maharashtra having around 30,000 millions of the power consumption. So the capacity required for this is around 13 gigawatt. So Maharashtra government is planning to install 13 gigawatt distributed solar plants. What is the meaning of distributed solar plant? So presently the thermal plants are concentrated thermal plants. Like the thermal generation happens in the Chandrapur, Koradi, Bhusawal, Parali, and the power is transmitted to the load center which is generally in the Mumbai, Pune and this Nashik region. So power is generated in one area and it is transmitted to the other area. But this agriculture solarization part is concerned with the distributed solar plants. So the solar plants having the capacity of 2 megawatt to 10 megawatt are generally constructed near the distribution substation. The power is connected to the local distribution substation and that power is consumed in the local vicinity. So earlier the agriculture consumers in the Maharashtra are getting power for the 8 hours. That too in the 2 shifts. So 50% of the consumer would get power in the daytime and 50% consumer would get power in the night times. So with the help of this agriculture solar feeder project, we are now giving the power to the agriculture feeders in the daytime. So it is also beneficial to the agriculture consumers because the agriculture consumers need to go in the night to irrigate their farms. So it is also a blessings to them also. So it is very a good project. It has been taken care by the government of India and it is probably the first project in the entire India which MSEDCL is implementing. 2054 megawatt are commissioned and the total target is 13 gigawatt. The other scheme is deploying agriculture solar pump. So it is also a very popular program in the state of Maharashtra. We have started this program since 2018 and it is now becoming a very popular program for distributing the solar off-grid solar pumps to the farmers. So deploying agriculture solar pump, it requires to just install a solar panel in the farm and a solar pump. So it is not having any revenue expenditure, like consumer has not to pay a single penny after installation of this pump, only capital cost. And that too government of India and government of Maharashtra has taken care of around 60 to 70%. In the last year 90% is being subsidized by the government and only 10% has to be borne by the consumer. So it is also a very popular scheme. And till now around 6 lakh solar pumps have been installed in the state of Maharashtra. And the proud moment for us is that we have got the Guinness World Record in Aurangabad. So by installing 45,911 solar pumps in a single month. So you can imagine installing 45,000 pumps in a single month was a big task, but our engineers has done it. The third issue is that energy procurement from the solar power. So as I said earlier, the distributed solar is one thing and concentrated or combined solar park is one other concept, where in the barren land, megawatt capacity is generated and that power is procured by the MSEDCL. So it also helps in achieving the solar renewable energy integration in our system. The rooftop solar scheme, as you may be aware of this, providing rooftop on the houses, so it will reduce your bills. So this scheme is also getting popular in the state of Maharashtra, and it is also being subsidized. Around 60% cost is borne by the government and consumer has to spend for the 40% only. The benefit of the rooftop solar is that once you provide the rooftop, after that there is no any electricity bill to the consumer. Literally lakhs of the consumer have benefited by the zero bills in the last 1 year. So around 5 to 5.5 lakh consumers have opted for this rooftop solar and they are enjoying the benefits of rooftop solar. The other part is solar panel on government building. So all the government connections we are going to convert to the rooftop solar. So this is also a big project. At the same time, we are also solarizing MSEDCL every office through this rooftop solar. And then 100% solarization of the villages. In the state of Maharashtra, we have selected some 100 villages. So these villages will be converted to the 100% solar village. And till now, around 20 villages have been converted to the solar villages. And they are enjoying the solar power like anything. So these are the steps MSEDCL and state of Maharashtra has taken to go for the renewable energy. And basically our focus is on the integration of the solar energy into the grid. So while integrating all this solar energy and renewable energy into the grid, there are various challenges. So first of all, I would like to tell you, because the thermal energy and solar energy, if we compare, so thermal energy is the dynamic energy and solar energy is like a static energy. So in case if in a grid some emergency occurs, like sudden shift of the load, if load rises or load reduces, so in a thermal plant what happens? Immediately it has been sensed by the governor and governor controls the steam input to the turbine and accordingly the power output is adjusted. Whereas in the solar panels there is no such facility. The generation of the solar energy or electrical energy through solar depends entirely on the sun rays and sun radiation. So if suddenly there is a change in the load, it will not be taken care. So there are some challenges. So number one challenge is the high generation and low demand in the future. So presently what is happening? We are going for the tremendous solar energy in the system. So daytime we are having surplus power. But at the same time, in the evening time and especially in the peak hours, we need to procure power from the grids. So in the evening time, this procurement of the power from the grid is a costly affair because the power available in the grid is generally thermal and hydro. So it is a costly. Solar energy is available at the rate of ₹2 per unit, whereas in the night hours, sometimes we have procured energy from the grid at the rate of around 12 rupees per kilowatt hour. So it is changing our financials every time. So this is one of the challenge to us. Then weather dependent output, if suddenly cloud covers there, so there will be a drop in the generation of the solar energy and it will affect our total generation, and then we need to again go to the power exchange to procure the immediate power from the exchange. Then grid instability due to fluctuations. So as I said earlier, it is the static power. Solar power is the static power. So sudden changes in the grid, it cannot take care. So you might have came across the examples of the Sri Lanka and Europe grid. So in Sri Lanka, there was a breakdown in a single line and it finally affected the entire grid and there is a dark out. Similarly, in the Europe, probably in the last, I think, April 2025, the three countries, I think Portugal, Spain and France, they have faced the massive power shortage due to the failure of the one interconnected grid. So such system occurs. We have solutions for these challenges. then need for storage solutions. So of course, the renewable energy are the infirm energies. These are not the firm. Like thermal energy is a continuous, you can generate it, but solar energy you cannot generate it beyond if there is no sun. So for this purpose, the storage solution we can go for, and we can store this energy and use when these energies are absent. Then high initial infrastructure cost. So initially when this solar concept came, around 16 to 17 rupees per kilowatt hour was the cost. But now with the scaling of this product, presently this power is available less than 2 rupees. So it is now in the control. Managing the demand. So demand side management it is called as a. So we are incentivize the use of power in the daytime. So one who uses this power in the daytime will get the rebate of around 80 paisas. If he uses this power in the peak time, he will be charged extra 1 rupees. So this will definitely create the mentality of the consumer to use the power in the daytime. I also request you people to use the power, maximum power in the daytime. So two types of energy storage. One is distributed energy storage and one is concentrated energy storage. So energy storage is being deployed in the transmission level also and distribution level. So basically agriculture consumption and solar power is the complement to each other. So when there is a requirement of irrigation in the power, when there is a sun, when there is raining, it won't require any power. So it is the best suited power for the agriculture sector. So we are going for that. Then promotion of upgrade solar pumps. So presently government of Maharashtra has taken decision that no conventional electricity will be given to the agriculture field, only solar pumps will be given. And the existing solar load will be converted to the agriculture load. So all these steps will definitely going to add the additional renewable energies in the state of Maharashtra, and probably by 2030 we will cross the target of having more than 50% renewable energy in our system. If you have any questions and answer, we will have it. Thank you.